Hi everyone, it's a beautiful day to learn, so let's take a look at the basics of IP addressing. By definition, an IP address is a numerical label that is assigned to a device connected to a computer which uses the Internet Protocol for communication. Example is 202.175.10.1. When we look at the anatomy, the IP address is comprised of 4 octets. We name here as A, B, C, and D. And each octet is comprised of 7 bits. So all in all, when you sum all the 8 bits, you have 32 bits length of an IP address. The IP address is divided into 2 parts. Some of the bits belong to the network address and some of the bits belong to the host. So that portion is actually adjustable. The IP address, more specifically the IP address for version 4, is comprised of 32-bit address. It is a logical address, meaning this when your computer starts up and it acquires an IP address, when you restart it again, there is a possibility that that IP address will not be the same IP address that will be assigned to it. So in short, the IP address is not permanent and unique to that particular computer. Okay? The IP address has a range of 0 to 255 per octet. So the values that could be placed in A, B, C, and D octets starts from 0 and the maximum number is 255. Therefore, the lowest or the smallest IP address that you could have is 0.0.0.0, and the highest will be 255.255.255.255. No, that's 4255s. Similarly, we call this kind of notation as a dotted decimal notation. So again, we read the IP address given here as 172.16.254.1. Let's take a look closer at the IP address classes. Of the total number of IP addresses, this is divided into 5 classes. Class A, B, C, and D. In each class, the first octet starts with a certain range. For example, in class A, it starts with 0 to 126. In class B, it starts with 128 to 191. Class C is 192 to 223. Class D is 224 to 239. And so for class E, 240 to 255. But take note that only classes A, B, and C are usable IP addresses, which means those that you could assign to your networks and your computers. Yeah, so looking at it, if it's a class A, the start address is 0.0.0.0, and the maximum IP address that you could assign in a class A is 126.255.255.255. So similarly, if you look at the higher class, class C, the lowest number that you could assign is, or the lowest IP address is 192.0.0.0, and the highest IP address is 255.255.255.255. You may notice that some of those numbers are not present in the range. Like for example, where is 127 between class A and B, right? So those numbers are missing intentionally because they serve a special purpose, which we are going to take a look in a later slide. Examples of the IP address below, you can see you have class A 10.10.5.1. For class B, you have 128.15.4.20. And for class C, you have 3 examples there. 192.168.0.1. Can you identify which of the following are valid IP addresses? The items colored red those are invalid IP addresses, and those with blue, they are valid, but somehow uh, they are special IP addresses. Let's take a look. So letter C, you have 256.10.10.10. It's invalid because the first octet is 256. That's beyond the 255 as a maximum number. For letter D, it starts with 127, 127.0.0.1, which is actually is a special address, which is a loopback address. And the next is letter E. It starts with an IP address 224, which is mentioned as a reserved IP. Item G. This is an invalid IP address. Can you guess why? Yeah, because it contains 5 octets. Remember, we only have 4 octets in a valid IPv4 address. Of the more than 255 billion IP addresses, some of them are actually special IP addresses. Like for example, the 127.0.0.1, that is called the loopback address, which is actually the local host, if you can notice it from your computer. We also have the network address and the broadcast address. These are IP addresses also, but assigned in as the network address or the group name of a certain segment of a network. And the broadcast address is something that you use to send a message to all the computers in the network. A typical example is the limited broadcast 255.255.255.255. And of course, we have private addresses like the one below. These private addresses are the ones you use in your local area network. No? So if you're going to have a computer shop and you have 10 computers, then you will be using these local IP addresses or private IP addresses. So similarly, if you have a home network or home office network, the numbers that you are going to assign to your devices most probably are these numbers from classes A, B, and C. And these are not usable in the internet. So meaning you cannot have this address as a real IP address that can be used to communicate over the internet. So examples, class A, it starts with 10.0.0 and ends with 10.255.255.255. And class B is 172.16.0.0 up to 172.31.255.255. And last is 192.168.0.0 up to 192.168.255.255. So that is normally, the class C network is normally what we use in most local area networks in small and medium scale setting. Now take a look at the examples. You have here special address for class A, B, and C. You have 10.0.0.1. I'll just pick one. Okay, so class B, 172.16.0.1, and class C, the third item there is 192.168.255.254. A network is typically divided into smaller networks, which we call a sub-network. And even if the computers and devices are interconnected with each other, it is sometimes more practical to divide them into several domains and assign them separate network IDs. So in this example, the entire network is divided into 3 areas. We have area 1, area 2, and area 3. And each group of network actually have their own network ID. So area 1 had a network ID of 192.168.1.0. Area 2 has a network address of 192.168.2.0, and the same thing with area 3, which has 3.0. That is their network address. Now, so a network address is a group ID. It is not used by any computers, but that is one single address that identify the group or that particular subnetwork. So therefore, in a network, you have groups, which is the network, and you have hosts, the members of the group. So of the total number of IP addresses, you have 32-bit. You have to assign a portion of that which represents the total number of networks, and the remaining will be the total number of hosts in a particular network. Right? So let's take a look at the examples basing on the class A, B, and C. In a class A network, the first octet actually belongs to the network segment, which is 8 bits. When you move on to class B, you have two 8 bits, which is 16 bits as part of the network, and 16 bits also as part of the host. When you move down to C, you will see that the number of networks is 3 octets. So you have higher number of networks and smaller number of hosts. So that means in a class A network, you can only form about 256 groups or 256 networks. But in each network, you can have as much as 16,777,216 hosts in a particular network. So that's very big of a group. Whereas when you move on to class C, you can have more groups. However, you can only have maximum of 256 devices, computers in that particular network. So now, if you're going to design one for your organization, so you have to decide which class you are going to use depending on the size. However, the problem is you are only limited to class A, B, and C. So there's if you have 200 less than 200 computers, you go to class C. But if you have 300 computers, then you have to move on to class B, in which case the number of hosts for that particular class is 65,000. So you will be using only 300, and the remaining 65,000 plus is unconsumed or wasted. So that's the problem of this kind of class full IP addressing. Now, to arrive at those numbers, you just have to take a look at the figure below. In a class A, you have 32 bits. If you add all the ones, that will give you 255. That's 0 to 255, so that makes it 256 networks all in all. And in class C, you have octets, which is 24 bits. So that's 2 raised to 24. That will give you 16,777,216 networks networks all in all. Right? Now, can you determine the class and give the number of networks and the number of hosts? Okay, so in class A, sorry. So in number 1, 202 is a class C network. So therefore, you have 16 million plus networks. That's 256 available hosts. Number 2 is 192. That is a class C. It's similar to number 1. Number 3 is a class A, which has only 256 networks and about 16 million plus available hosts. And class B, which is an even, you have the same number of hosts and the same number of networks at 65,536. Right, so that's it for the basics of IP addressing. I'll see you again in the more advanced topic of IP addressing.